Let's talk about big data. Actually, yep, that's better. I know this word gets overused, but sometimes you really need to distribute your data processing. Sometimes really a single machine is not enough, and your data doesn't fit into memory. And there are many ways to actually do it, but we in Allegro, among other tools, use Apache Spark. We're a heavy user of Apache Spark, and we can program Apache Spark jobs in multiple languages. We can use R, we can use Java, but most importantly, we can use Scala or Python. I'm Jacek Kołodziej. I wander through metal shows, through hills and mountains. I run long distances. Together with my girlfriend, we live with these two gentlemen over there. And also, I'm a software engineer at Allegro, where I work at a team responsible for offer recommendations. And that means data. Yeah, warm up. First, physical warm up. How many of you program in Python? Sure. How many of you program in Scala? Any other JVM language? Nice. Okay, because there will be quite a lot of JVM in this presentation for a Python meetup at least. So here's Scala. Here are some. Do you see it? Okay, I hope you do. Here are some imports. We are importing a bit of types, a bit of Spark important classes, and this third line, don't worry about it. We will write something, let's say, hello worldy in Apache Spark. We will make it show us some data. First, what we need is a Spark session. Basically, it's something like an interface to Spark for our code. To get a Spark session, we need some builder. We need to point it at a Spark cluster, but also we can run it locally on our local machine without any like external real cluster. Hence this local asterisk thingy. We need to give our application a name and call get or create, and that's basically it. We have a Spark session. And here's Python. And despite some syntax differences, this code pretty much does the same thing. It also imports some types. It also constructs Spark session. Does this voice really bothers you, or this? It's okay. Okay, thank you. Next, we will make our code return a data frame, a Spark data frame. First, we need to define a schema. Our schema will have two fields. First field will be of integer type, and we'll call it A, and the second field of type double will be called B. And we will create some data for this data frame. This is basic, very basic data frame. It will have 3 rows. First row with 2 in field A, with number 3 in field B, and so on and so forth. And this is how it looks in PySpark. And you can see that everything is basically the same, only in Python. The only difference being that in Python we can use keyword arguments for these row objects, and in Scala we can't. And otherwise, this is basically the same stuff. The last thing that we need to add to our warm-up object is a main method. We need to accept some command line arguments, but we won't actually use them here. This method first gets the Spark session. Second, it creates the data frame using the methods defined earlier, and it will print the schema of this data frame, show the excerpt of this data frame, but this data frame is very small, so it just shows the whole thing. And for the sake of completeness, it will stop the Spark session. And again, here's the Python counterpart, which basically does the same stuff. with your familiar if name equals main. Yeah, you know the stuff. How to run it? For Scala, we need some small configuration file where we specify some dependencies. We need something called SBT, that's Scala build tool, and this will package our code. It will create a jar file together with the dependencies needed to be run. And also we need something called Spark submit. This is the utility for submitting a work to Spark. And since we already defined the main node in our code, this local asterisk, we don't need to repeat it here, but we need to give Spark submit the class to run and also the path to this jar file, and that's it for a local run. In Python, we can make a little bit less typing, but it's pretty much the same stuff. We install some dependencies. Of course, I recommend using virtual env, but we can make it as simple as this line. We can also freeze our whole tree of dependencies, but yeah, again, we can just do pip install PySpark and then run it as a Python module, like you would do with every other Python module. And what happens if we do it in either way? In Scala, we see some information about compiling, some warnings, some information, I don't care. But most importantly, we will see the schema of this data frame printed out and the contents of this data frame printed out. And same for Python, save for the compilation, of course. We see the schema, we see the data frame's contents. What happened underneath? For Scala, it looks pretty much like this in general for Spark. In local mode, it was a bit simpler, but when we are running Scala Spark applications, we have one JVM process that we call a driver, which will communicate with Spark executors. The driver will send instructions to these executors. It will, in this case, it would also transfer the data over the some form of inter-process communication, for example, over the network. This sending process needs serializing data and deserializing in executors. And on the way back, the data also needs to be serialized and deserialized, so the driver can for example, print the contents of the data frame. And for PySpark, it's a bit, well, more complicated. The communication between Spark context, like this JVM one, this blue one, between this and between Spark executors stays pretty much the same. But when we run our Spark code as a Python module, we can call this module a driver, and in order for it to do anything with Spark, it needs to communicate with a JVM process. And there's some magical thingy called Py4j, which allows just that. It allows calling JVM objects from Python code and vice versa. It also allows to translate Pythonic objects into JVM ones. Well, I can't really dive into specifics, but this is how it basically works. This adds another layer of serializing and deserializing, and also this translation process. So this is, and we have already some overhead for PySpark, but it works. How does typical development with Apache Spark look like? Well, for development, we need to be able to test our stuff. Let's say we have a method or a function called group and count, which will group and count stuff. And we want to make some test, create a test to test this. How can we do it? Well, for Scala, we start with choosing some Scala testing framework. I have used Scala test here, and we create a class that that extends some Scala tests base classes. We then start the test with creating a Spark session, just as we did in our Hello World. And for PySpark, again, pretty much the same stuff. I have used PyTest, of course. I have made a Spark session fixture, and how the actual test look like. The test in Scala starts like this. Then we are getting the Spark session. I have used here this create data method that I defined previously for in order to have some like sample data to work on, and then called this group and count that we want to test. Then call a collect method that is a Spark method that fetches the data from executors back into the driver process, and then call some assertion in this weird Scala way. But yeah, it works. It is basically a set comparison. In Python, yeah, this is a typical PyTest test. We are getting a Spark session. We are creating some sample data. We call the group and count. Then again this collect thing, and do a set comparison as in Scala version, and it works. But these slides could lead you to believe that these two approaches, the Scala and Python, are almost exactly the same. Well, no, these are still very different languages, starting with typing, of course. Scala is strongly typed, and it's statically typed. This means that quite a lot of mistakes that we are making during development are catched during compilation phase of our development loop. Python also is strongly typed. For some definition of strongly, don't email me about it. But it's also dynamically typed. That's why, to be equally sure in our code, that our code does what we want it to do, we need to write more tests or do more static analysis on this code. I strongly recommend using optional type hints for that, and some type checker, for example, MyPy. It makes life with Spark, and not only in Spark, much better. Speaking about development, Spark gives us a few APIs to work with. We only need to choose one of them. We can choose more than one, but yeah, here are our options. The most low-level one is RDDs. From the developer's perspective, it's basically working with tuples with some small API over that. Some higher-level API is data frames, and what you have seen on the previous slides is basically using data frames API in Spark. Spark offers you an API called datasets, which are very native way of working with JVM objects that are statically typed. And as you can guess, you can't have statically typed code in Python, at least not in CPython. So this is available only in Scala. There's also an API called Spark SQL. If you want to write more in a SQL manner, as long as Spark SQL supports operations you need, you can use Spark SQL. There's a tool called UDFs, user-defined functions. When above APIs are not enough for your use cases, you can create your own transformations in Python or in Scala through UDFs. And while in Scala, this is just some additional code that we are running over our data within the same JVM processes running on the same JVM objects. In Python, this is heavier, because when you look at this diagram on the right, that suddenly got a little bit bigger down below. What the Spark needs to do in order to run UDFs in Python, it needs to spawn in Spark on Spark executor nodes additional Python workers. And this means not only just spawning some workers, it means extra communication with these workers. So Spark executor being in JVM needs, in addition to what it already does, needs to translate the objects to Python form, and of course also serialize and deserialize the data and send it to worker, wait for it to do the work, and then get it back, going through all the serializing, deserializing, and translating stuff over again. And this means overhead, of course. So yeah, to sum up, in PySpark, just as in Scala, we can use data frames, we can use Spark SQL, we can do UDFs or RDDs, but both with this serialization overhead, and we can't have datasets. Okay. I've talked about differences between languages, but it's not only the language that we need to consider. We need to also consider ecosystems of these languages, and they're quite big. Both in Scala world and in PySpark world, we can use Spark like libraries for either structured streaming or machine learning. These are both available both for Scala and for PySpark. But there's a library called GraphX for graph operations, and we can't use it, at least not directly, in PySpark. This is because, well, Apache Spark is actually written in Scala, and whatever new thingy will be implemented in Spark, it will be available in Scala first and in Python second, maybe. Well, we wait for GraphX for quite some time now. On the other hand, there's some wrapper around GraphX. I haven't used it, but yeah, it's available. On the other hand, Python ecosystem is quite rich. We have NumPy, we have Pandas, we have Koalas, which is like a Pandas-like API over data frames, over Spark data frames. Sorry, and also we have a multitude of other things, tools, libraries, frameworks in Python. So maybe it's nice to use PySpark if we can leverage that. On the other hand, the Scala isn't some niche language. It also has its ecosystem. I'm not here to list every option that you can use. This is probably outdated anyway already. What I want you to think about is which ecosystem will benefit you more when writing your actual project, and think about what do you and what does your team already know about from this ecosystem? What are the competences of the team you are working with, or what are the ambitions of that team, and what does this team want to get to know or wants to practice? Okay, back to the meaty stuff. Let's say deployment. How do we deploy our code in either Scala or PySpark? If we if we use Spark with Scala, in order to send it to cluster for processing, we need to first package our stuff and package it with dependencies to something called FOD-jar, which will be deployed over to the cluster, and that's it. In PySpark, our dependencies can be put in a zip file. We can even archive our entire virtual env and send it over to for example, a Hadoop cluster, and we can even install our dependencies directly on the worker nodes. It depends on our requirements, our I don't know, whether we have a long-lived cluster or we just spawn ephemeral ones in some cloud. There are many options. But then we are using the already mentioned Spark Submit. We use it in production too. We pointed at the cluster itself, and in Scala we need to pass it the class to run, and this path to jar file, and the Spark will know what to do with it. It will run the my class. In PySpark, similarly, we transfer over any Python files we want. We transfer any archives we want to the cluster. Spark will know what to do with them, and we point it at our main Python module, and again it will run without problems, hopefully. When thinking about which way to choose, we will probably want to think about future maintenance. We want probably our project to live on, not be like throwaway stuff. So how does the maintenance look? Okay. Again, team's competences. What does your team already know, and what does it want to know? For example, my team is currently like 50-50 Python JVM. It used to be more JVM. Probably it will change in the future, I don't know. But it is a strong thing to consider. Which ecosystem will be easier to work on in your team? Collaboration. And again, our example is that my team collaborates closely on some part of the code with a research team that is very proficient in Python, but not exactly in JVM technologies. So for some code bases, this is a very strong signal that we should use PySpark for some code, because the collaboration will be faster, will be easier, will produce results, I don't know, faster and better ones. Typing is something very valuable, and possibly other language differences. Again, Scala and Python differ quite a lot, and some aspects of the language can slow you down or make you faster. Typing in Python will probably slow you down a little bit, but development with Scala is slower because of compilation time. The development loop in Python looks like this. You make a change, you run tests, and make another change, and go on. In Scala, you make a change, you compile the code, and then run the tests. And sometimes it doesn't matter, sometimes it does. And in maintenance, tools play a big role, at least sometimes. Tools for static analysis, tools for profiling, for testing. This can impact your development quite a bit. There's this thing called popularity, and popularity can just be some number, but for me, popularity is an indicator of how fast will I get support for my problems, probably. Either like paid third-party support or community open source support. I don't have a strong idea how to count popularity, but I've looked at the numbers in these developer surveys. I've only looked at answers where someone mentioned that he or she is a Spark developer, he or she uses Apache Spark, and from that subset, how many of them also ticked Scala or Python, or both. And the percentages look like this. What doesn't tell me were nothing really, because this is a very poor statistic, to be honest. But there are at least some Scala and some Python professionals that use Apache Spark. That's okay. I also counted Stack Overflow questions, looking by those tags, and the numbers are, well, the only thing that it helps me think is that I will have no real trouble getting support for either. So yeah, that's it for popularity. Maybe if I would use some very niche language, but I can't with Apache Spark. And of course, performance. So to measure performance some way, I make a simple job for Spark that just selects data from one of our bigger tables and save it in some other place. And the numbers look like this, and they are exactly the same. And what happened? Well, the only difference between running this select and save in Scala versus PySpark is that we interfaced with Apache Spark using different language. But underneath, Spark did exactly the same thing. This is what happens when we are using, for example, Spark SQL or data frame API. Okay, so let's see some differences. I've modified this job, and I'm adding a column using a UDF. And for Scala, this code took like 2.5 minutes, and in Python it took over 4. Okay, so clearly adding a column in UDF in PySpark takes more time. And if your use case is exactly this is very useful information. For all the other use cases, well, such tests can give you some intuition about UDFs, but you heard it already just by looking at this diagram with added Python workers. For all the other operations, well, you need to benchmark yourself, because it's very hard to generalize some such like hello world benchmarks onto your code. So at least until this is exactly the thing you are doing in your code, this benchmark, I think, is worthless. Anyway, I can't possibly give you a simple answer what to choose. I can't, because this is very, very contextual. But I can give you some hints. Start with functional requirements, because first and foremost, your code probably needs to do something. And I would place much more focus on the tools that are provided with a language, right? With the ecosystem that goes with that language, than on the language itself. Second, performance. But does your job really need to finish in some exact time? Well, for us in Allegro, some jobs really do have an SLA. They need to finish by some time in the day, and some not. So ask yourself, is your performance requirement real, or only some number to look at while neglecting other stuff? Think about competencies of your team, of the maintainers of the job you are writing. You will write both present maintainers and future ones. This makes a difference sometimes. And other non-functional requirements, which will, of course, impact your daily life with the job afterwards. Like how easy it is to test your job, how much, for example, typing makes your job with that code easier, and other stuff. I would start with this one. So I guess that's all from me here. You will find these slides on in this link you are seeing. Also, don't forget to check out allegro.tech, where you will find our tech blog, data, not data, front end, well, quite a lot of stuff. And yeah, thank you. That's it. Do you have any questions?
Thank you for your lecture, and please tell me what's the typical size of the data frame you're operating with the Spark on?
What is the typical size, or maximum, or
both informations are welcome.
Okay, so we daily interact with data that is on the order of gigabytes or terabytes sometimes. It is strongly dependent on the team, on which part of the platform are we talking about. But yeah, gigabytes, between gigabytes or terabytes is our daily work.
Is there in practice any difference between these both environments in the maximum volume you can operate?
Mm-hmm. And this depends on one thing. Whether we are like in a typical scenario, performance boils down to this: whether we are using data frames API with or without UDFs. In a typical development life with Spark, between Scala and Python, this is the biggest difference. So yeah, the UDFs are pretty much have the biggest impact here.
Thank you very much.
Thanks for the talk. Of course, a question from me. Regarding the performance and already mentioned UDFs, you did a comparison on UDFs that operate on a single row or on a series from the pandas. There is like two options to run the UDFs. One is promised to be faster.
To be honest, I can't remember. I probably did the second one, this one on the series, but I didn't want to point out at exact difference, but just to show you that the difference exists. So yeah, so it would be faster. It would be slower in both cases, but yeah, you're right. It should be a little bit faster on series. Yes.
Thanks.
Is it possible to implement a window user-defined function in PySpark?
Implement, sorry,
Windowed.
Windowed.
Yeah.
Can we do windows in?
I know that it's possible to implement a window function, right, and the user-defined function, but can we mix it?
Certainly, we can make window functions with data frame API. I think I'm not sure. I think in UDFs too, but I'm not sure about it.
One more question. Could you indicate the limitation or differences between the RDDs and data frames in PySpark, of course?
I think that makes quite a lot of articles. But like in this year and age, I would start always with data frames, and I don't see quite a use case for RDDs right now. But yeah, it probably depends. Absolutely, yes. Also from the performance standpoint, because when we are using RDDs, the Spark is forced to execute exactly our code. When using data frames, it can optimize it in a lot of ways, and it change in each Spark release. So it can have better and better optimizations. So another reason.
You show the examples comparison between PySpark and Scala, but as I understand, as a script, and how with usage from notebook when the person is working in the interactive way. Mm-hmm. Is there some similar comparison? Because in this case, the compilation happens every time when person clicks submit.
Okay, let's say I just know that there are kernels for both PySpark and Scala, and I didn't use the Scala one, so I'm not familiar with how it works underneath. But certainly, you can work interactively with Scala in notebooks, and not only. There's also some REPL, I believe.
Okay, thank you very much, Jacek.
Thank you.
Wielkie brawa dla Jacka.